All right, let's jump right in. We're going to be talking about a threat that, believe it or not, affects more than half of the entire world's population. It's a danger that travels silently, sometimes in our own backyards, and sometimes across continents in just a few hours. We're talking about vector-borne diseases.
But before we get into the heavy stuff, I want to ask you a question. Just think about it for a second. Forget the usual suspects, sharks, lions, snakes. When it comes down to it, what animal do you think is responsible for the most human deaths?
You might be surprised. The answer, and it's not even close, is the mosquito. And this tiny little insect is the perfect way to start our conversation because it is, by far, the world's most effective and deadly vector for disease.
Okay, so to really understand how we fight back, we first have to get a handle on what exactly we're up against. What even is a vector-borne disease?
Well, a vector is basically a living delivery service for germs. Think of it like that. It's any organism that picks up something nasty, like a virus or a parasite, from one animal and carries it over to another. Mosquitoes are obviously the most famous. But yeah, ticks, flies, and fleas are all members of this pretty dangerous club.
And the sheer scale of this problem is, well, it's just staggering. I mean, we are not talking about a small issue here. Just look at malaria. That alone is over 200 million cases a year. Then you add in dengue and lymphatic filariasis, which is this awful parasitic disease that causes extreme swelling. You start to get a picture of the incredible global burden these tiny creatures cause. Now, you might be thinking, hey, with all our modern medicine, shouldn't this be a problem we have under control by now? And you'd think so. But the reality is, this isn't just some lingering problem, it's actually a growing global menace.
And that's what's so wild. It's a total paradox. On the one hand, yeah, we've had some huge wins, like cutting the world's malaria risk area in half. But on the other hand, the fight is so far from over. Dengue is just exploding, Zika spread like wildfire a few years back, and hundreds of thousands of people are still dying from malaria every single year. So what's going on? Why, with all our technology, is this threat getting worse?
Well, it's because we're basically facing a perfect storm of modern problems. Our world is so interconnected now that we've given these pathogens a global passport. Unplanned cities create these perfect, dense breeding grounds for mosquitoes, and then you've got the huge forces like climate change that are literally expanding the territory where these vectors can live and thrive.
Just let that sink in for a minute. Modern air travel has completely changed the game. Someone can get infected with a virus like dengue or Zika, hop on a plane, and land on a different continent before they even feel sick. And in doing so, they could introduce that disease to a whole new population of mosquitoes ready to spread it.
So, with the threat moving faster and faster, our defenses have to get a whole lot smarter. This is where surveillance, our global watchtower, if you will, becomes absolutely critical.
You see, the point of modern surveillance isn't just counting sick people after it's too late. It's all about being proactive. It's about spotting outbreaks before they explode, it's about tracking how these diseases are changing, and it's about mapping out the highest risk areas so we can get our resources exactly where they need to be.
And the tools we're using now are incredible, almost science fiction. I mean, take satellite forecasting. There are systems, like one called DMOS, that analyze data from space, looking at things like rainfall and temperature, to predict where a dengue outbreak is likely to happen, sometimes months before it does. We're also becoming disease detectives on a molecular level. By sequencing the DNA or RNA of a pathogen, we can create a kind of genetic fingerprint. This lets us track exactly how a virus like Zika is moving from place to place and see how it's evolving as it goes. It's amazing. And of course, artificial intelligence is getting in on the fight. Machine learning models can chew through these massive, complex datasets, like years of weekly case numbers to spot patterns that a human never could, and they can predict future outbreaks with really high accuracy. That gives health officials a crucial head start.
So if all that is our watchtower, what's actually in our arsenal for fighting back? Let's take a look at some of the really cutting-edge stuff being developed for tomorrow's toolkit.
Okay, I absolutely love this one. It's called xenosurveillance, and it is just brilliant. Instead of trying to go out and find and test thousands of animals for disease, scientists just test the mosquitoes that have been feeding on those animals. The mosquitoes literally become tiny, flying data collectors, giving us a perfect snapshot of what diseases are circulating in the local wildlife. So clever.
And then you have genetic engineering.
The Precision-Guided Sterile Insect Technique, or PGSIT, is a total game-changer. Scientists edit mosquito genes so that when they release eggs into an area, only sterile males can hatch and fly. These males go on to mate with the wild females, but they can't produce any offspring. So with each new generation, the local mosquito population just completely collapses.
But here's the thing. Technology, no matter how cool it is not the whole answer. The final piece of this puzzle, and maybe the most important one, is recognizing that this is a responsibility we all share. You see, really getting a handle on these diseases requires a massive team effort. It takes governments setting smart policies, it takes communities organizing cleanups, it takes the private sector inventing new tools, all the way down to the small choices that you and I make in our own homes.
Of course, governments have a huge role here. They've got to make this a core part of their national health plans, fund all that high-tech surveillance, and tackle the big underlying issues, like poor sanitation, that help these vectors breed in the first place. And they also have to stay on top of the growing problem of insecticide resistance.
But really, it all comes down to action on the ground. Communities, families, we are the front line of defense. And simple things, like getting involved in local cleanups, cooperating with spraying programs, and this is the big one, just getting rid of any standing water around your house, these actions can make a massive difference by destroying the places mosquitoes breed.
So that kind of brings us to the final big question. We are in this high-tech arms race against some of nature's oldest, most adaptable killers. On our side, we have satellites, AI, genetic engineering, but on their side, they have billions of years of evolution. And the real question is, as we keep innovating, can our incredible human ingenuity finally, for good, outsmart these ancient threats? It's something to think about.